What if I told you that in the United States of America, there is a strong correlation between median household income and the price of a chicken sandwich? Hi, welcome to Math Fun Episode 2. Today I'm here to talk to you a little bit about causation, causality, correlation, correllality. Now, at the beginning of the video, mere seconds ago, I mentioned that there was a strong correlation between median household income in the United States of America and the price of a chicken sandwich. Now, I'm here to talk to you today not only about strong correlation between two seemingly uncorrelated things, but I'm also here to try and understand why it is that there is no correlation between median household income and the price of a cheeseburger, weak correlation between median household income and the price of a Caesar salad, moderate correlation between median household income and the price of cheese fries, and of course, strong correlation between median household income and a chicken sandwich. So I took it upon myself to do a little bit of research into the population size, median household income, and price of various food items across 10 different states with varying population sizes. So these states include New York, Wisconsin, Hawaii, Arkansas, Louisiana, Colorado, California, Pennsylvania, Oklahoma, and Ohio. So between these 10 states, the median household income varied between $45,000 and $75,000, and the population size for that state went from about 1.4 million to 39 million for California. So taking a look at the results of the calculations that I did through Excel, I have an R-squared value from the trend line that we fit to each of these scatter plots. And I take the square root of each R-squared value to find out what the R value is. And that R value is going to give me a rough idea of the correlation between the two variables that I'm looking at. So here that is various food items and median household income. So let's take a look at this first graph here, cheeseburger price versus median household income. Now here, going to three significant figures, the R-squared value and the R value are each 0.000. There is absolutely no correlation between these two things. Moving on to our second pairing, Caesar salad versus median household income. So here we see the R-squared value is 0.016, R value of 0.126. by taking the square root of that R-squared value. So for Caesar salad versus median household income, we have 0.126, which is really just a weak correlation. Nothing impressive yet. Now moving on to cheese fries price versus median household income, we started to see an R value that's a little bit greater, 0.429 as the square root of 0.184. And 0.429 is right in the moderate correlation range. And we can see we have a nice positive slope over here. And finally, looking at the pièce de résistance, the chicken sandwich price versus median household income in the United States of America. R-squared value 0.397, R value of 0.630, rounded up from 0.629999999. So I just want to get into the R value for a moment. I did bring it up before without giving it proper introduction. The R value is a value that varies between -1 and +1, and it is the end result of calculating the Pearson Correlation Coefficient. So R is an indicator of how far away the points in your scatter plot are from the trend line that you use to fit it. If you have a Pearson Correlation Coefficient of +1, that is a perfect correlation, a perfect positive correlation, and it means that you have a trend line that tends upwards, a positive slope, and every single point in the scatter plot is exactly on the line. The same thing happens with a -1. That means that you have a perfect negative correlation, and these two things never really happen in reality. In this case, we have 0.63 for the correlation between a chicken sandwich and median household income, and that was a strong correlation, and that means that these points were not too far away from the trend line that was passing through them. So that basically sums up this episode of Math Fun. For those of you who have just discovered this page for the first time, give it a subscribe, click that notification button, the little fancy bell over there. By the way, the bell also has a curve associated with it. We might talk about the bell curve or the normal distribution in a different video, but this has been a little bit of an introduction of a new concept to some of you in statistics, which is the Pearson Correlation Coefficient. Finally, before I let you go, I just want to let you know that just because there is a correlation between two things does not mean that there's anything further than that in terms of how each individual variable affects the other in reality. Have a great rest of your morning, afternoon, evening, or night.